पॉलिसी विभाग इस कार्यक्रम का संचालन करने जा रही है। वैज्ञानिक तथा औद्योगिक अनुसंधान परिषद CSIR को विज्ञान एवं प्रौद्योगिकी मंत्रालय के अंतर्गत एक प्रमुख अनुसंधान एवं विकास संगठन के रूप में 1942 में स्थापित किया गया। CSIR 37 राष्ट्रीय प्रयोगशालाओं, 39 आउटरीच केंद्रों और अखिल भारतीय उपस्थिति वाली 5 इकाइयों का एक गतिशील नेटवर्क है। 1954 में स्थापित CSIR प्रयोगशालाओं में से एक है। हमारा संस्थान वर्तमान में विविध एवं अत्यधिक अनुप्रयुक्त अनुसंधान क्षेत्रों पर केंद्रित है, जो मुख्य रूप से समुद्री संसाधनों जैसे नमक व समुद्री रसायन, जल शोधन, विलवणीकरण के लिए मेम्ब्रेन आधारित प्रक्रिया, नवीकरणीय ऊर्जा अनुप्रयोग एवं अकार्बनिक रसायन व सामग्री पर आधारित हैं। CSMCRI समुद्री शैवाल, सूक्ष्म शैवाल एवं लवण सह पौधों पर शोध के साथ विशिष्ट रसायन, बायोमास एवं CO2 व्युत्पन्न रसायन, स्वास्थ्य सेवा के लिए संवेदी एवं नैदानिक रसायन, प्राकृतिक उत्पाद, आणविक जीव विज्ञान, जैव प्रौद्योगिकी के लिए उत्प्रेरण और अपशिष्ट प्रबंधन आदि राष्ट्रीय स्तर पर महत्वपूर्ण विषयों पर कार्य कर रहा है। अपने वैज्ञानिक आउटपुट और तकनीकी उत्कृष्टता को दर्शाने के लिए संस्थान आज 10 अप्रैल से 14 अप्रैल 2023 तक 1 वीक 1 लैब कार्यक्रम का आयोजन भी कर रहा है। हम सभी के लिए यह बड़े ही हर्ष की बात है कि आज स्थापना दिवस समारोह में डॉक्टर बाला सुब्रमण्यम गोपालन विशिष्ट अतिथि के रूप में एवं श्री नीलेश एम देसाई मुख्य अतिथि के रूप में उपस्थित हैं। मैं स्थापना दिवस समारोह के मुख्य समन्वयक डॉक्टर विश्वजीत गांगुली से अनुरोध करती हूं कि हमारे दोनों अतिथियों, हमारे निदेशक महोदय डॉक्टर कनन श्रीनिवासन एवं प्रशासन नियंत्रक श्री सुभाष चंद्र अंतिल को मंच पर लाने का कष्ट करें। धन्यवाद। अब मैं कार्यक्रम के मुख्य समन्वयक डॉक्टर विश्वजीत गांगुली से हमारे विशिष्ट अतिथि डॉक्टर बी गोपालन का फूलों के गुलदस्ते, शॉल एवं पुस्तक अर्पण करके अभिनंदन करने का अनुरोध करती हूँ। अब मैं हमारे निदेशक महोदय डॉक्टर कनन श्रीनिवासन से हमारे मुख्य अतिथि श्री नीलेश एम देसाई जी को शॉल, फूलों के गुलदस्ते एवं पुस्तक देकर उनका अभिनंदन और स्वागत करने का आग्रह करती हूँ। कार्यक्रम को आगे बढ़ाते हुए मैं स्थापना दिवस समारोह के मुख्य समन्वयक डॉक्टर विश्वजीत गांगुली सर को स्वागत संबोधन के लिए आमंत्रित करती हूँ।
A very good afternoon. Chief guest of today's function, Sri Nilesh M. Desai, Director SAC in ISRO, Ahmedabad. Guest of honor of today's function, Dr. B. Gopalan, Scientific Advisor, IICT Hyderabad. Dr. Kannan Srinivasan, Director, CSIR-CSMCRI, Controller of Administration, Sri Subhash Chandraji. Dr. Parul, distinguished guests of the dais, former and present colleagues of CSMCRI, students, press, and media, on behalf of CSIR-CSMCRI family, I extend a warm welcome to you all on the occasion of the 70th Foundation Day celebrations of CSIR-CSMCRI. We thank Sri Desai and Dr. Gopalan for generously accepting our request to grace this occasion as chief guest and guest of honor. We are fortunate to have them here today with us. Today, we are celebrating 70th Foundation Day celebration of CSIR-CSMCRI in hybrid mode. It is a momentous occasion on account of many reasons. CSMCRI completes one more year of its glorious journey. CSIR-CSMCRI is one of the constituent labs of CSIR, works on salt and marine chemicals. CSMCRI research focuses on the area of marine resources with a vision to explore, harness, and transform, and works on marine and salt and marine chemicals, marine desalination, seaweed research to environment impact assessment. Today, this is a very special occasion because CSMCRI started 1 week, 1 lab campaign for 5 days starting on 10th of April to 14th of April 2023. This nationwide initiative, launched by Honorable Minister, Science and Technology and Earth Sciences Independent Charge, Dr. Jitendra Singh Ji, on 6th January 23, is to showcase the achievements of CSIR laboratories to the society through various integrative events. This campaign showcased the 70 years of achievements of CSMCRI to all walks of life, including school and college students, industry, stakeholders, farmers, scientists, teachers, and startups. This 5-day event is open from 9 to 6 p.m. and on behalf of OWOL, I invite all of you to participate in this campus with full enthusiasm. I once again thank our chief guest, Sri Desai, and guest of honor, Dr. Gopalan, for accepting our invitation with great promptness and be here with us in spite of their very busy schedule. On behalf of CSMCRI family, I once again welcome all our guests and all our dignitaries on and off the dais and connected through the visual platform in today's function. Thank you.
आज के विशिष्ट व्याख्यान और मुख्य अतिथि व्याख्यान की ओर बढ़ने से पहले मैं सभी मंचासीन माननीयों से अनुरोध करूंगी कि वे कृपया सामने की कुर्सियों पर बैठ जाएं। गोपालन सर बैठे रह सकते हैं। अब मैं आज के कार्यक्रम के विशिष्ट वक्ता डॉक्टर बाल सुब्रमण्यम गोपालन का परिचय प्रस्तुत करना चाहूँगी। डॉक्टर गोपालन वर्तमान में डिवीजन ऑफ क्रॉप प्रोटेक्शन CSIR IICT हैदराबाद में वैज्ञानिक सलाहकार पद पर कार्यरत हैं। उन्होंने 1976 में यूनिवर्सिटी ऑफ मद्रास से सिंथेटिक ऑर्गेनिक केमिस्ट्री में PhD उपाधि प्राप्त की। उसके बाद उन्होंने हार्वर्ड यूनिवर्सिटी में नोबेल पुरस्कार विजेता प्रोफेसर E.J. कोरी के साथ टोटल सिंथेसिस ऑफ गिबरेलिक एसिड पर कार्य किया। वे सिंटैक्स रिसर्च इंक कैलिफोर्निया एवं ब्रिस्टल मायर्स स्क्विब USA में भी रिसर्च एसोसिएट के पदों पर रहे। भारत आकर उन्होंने बूट्स फार्मास्यूटिकल इंडिया लिमिटेड, सन फार्मा एडवांस्ड रिसर्च सेंटर, ग्लैक्सो इंडिया लिमिटेड, ग्लेनमार्क रिसर्च सेंटर, मैट्रिक्स लैबोरेटरीज जैसी प्रमुख फार्मा कंपनीज में ऑर्गेनिक सिंथेसिस, ड्रग डिस्कवरी व डेवलपमेंट एवं नोवेल ड्रग डिलीवरी सिस्टम के क्षेत्र में उत्कृष्ट शोध व विकास कार्य किए। उनके योगदान से बने ओग्ले मिलास्ट फॉरेस्ट लेबोरेटरीज यूएसए को एवं मैलो ग्लिप्टिन मर्क जर्मनी को आउट लाइसेंस्ड हुए। डॉक्टर गोपालन अनेक राष्ट्रीय व अंतर्राष्ट्रीय समितियों के सदस्य भी हैं। उन्हें ग्लेनमार्क के द्वारा इन्वेंटर्स अवार्ड एवं फार्मास्यूटिकल साइंस में रेनबैक्सी साइंस फाउंडेशन अवार्ड से सम्मानित किया जा चुका है। डॉक्टर गोपालन के फार्मा एवं ड्रग रिसर्च क्षेत्र में 70 से भी अधिक पेटेंट्स हैं। इस संक्षिप्त परिचय के साथ अब मैं डॉक्टर गोपालन को उनके वक्तव्य के लिए आमंत्रित करती हूँ। सर, आपका स्वागत है।
Thank you, madam, for your nice introduction. And first of all, I'd like to thank the organizers for giving me an opportunity to be here to address this august audience. And I'm not going to elaborately discuss anything, but I'm going to say something about what is the actual difference between research done in institutes and also universities and industry. Because these are three different areas in which people work. Suppose in universities, they do mostly fundamental research, and in industry, they do applied research. And the research institutes of this type can do in between, because fundamental research is of utmost importance if you want to be successful to develop a technology. First basic thing is the basic science is important. So in this aspect, all of them are important. Suppose you have a very good idea in the university, and if it is not translatable to something useful to the society, then it will not see the light of the day. So both are important. And for the main difference is in universities, they work mostly on fundamental work, but the out-licensing model to industry is very, very important. They should have interaction with industry. Say, for example, in IITs, they are also educational institutions having research and teaching, but all of them do have a collaboration with an industry. They have a connection with the industry. Either it should be, they should take projects emanating from the industry, or they should collaborate with them, whatever is of interest to them. The purpose with which all these CSIR institutions were thought about by our former leaders like Pandit Jawaharlal Nehru and others, in instituting the CSIR, the mandate is to do research relevant to the small scale industries around, for the flourishing of the small scale industries around. That was the objective with which they started. But somewhere the research of the CSIR laboratories, they were doing excellent work, but there was no connect to the industry. So that means it amounts to the same thing as doing in the university. There is no difference. But of late, the CSIRs, they have a mandate that they should always collaborate with an industry. It is very, very important, because ultimately whatever you produce, it has to be utilized by common people. That is the basic crux of this whole doing research. But the blue sky research is done in universities. Their interest is only publications. Then publication number was very important initially. Then became, when so many numbers increased, then they put a rider saying that it should have a good impact factor. Then that also increased, and then they put another rider saying that the H index should be good. Like this, the standard has been increased in the academic area. So nowadays people publish in high impact journals and all which are having high H index is happening. And the second thing is the industry connect is very important. And in this, as far as this institute is concerned, there may not be many industries around in Bhavnagar, but still the agrochemical industries or the pharmaceutical industries, they are concentrated in Ahmedabad and Baroda. And you cannot give us an excuse that we are not getting good people, because even very difficult to get good people to start with. But anybody who is very good to start with may not be that good, but they are trained and inspired, and a lot of knowledge is imparted, and you make him good. That is one of the most important aspects of academician, because they should develop people and give it to the industry. So such is an important aspect. For that you should be knowledgeable enough, and you should update your knowledge because as today's morning you must have heard about that MP talking about artificial intelligence, and also so many things he talked about, very current things. But the thing is, gene expression at the gene level, they want to alter what kind of baby you want to get and what kind of intelligence it should have and all. They are in the very initial stages, but they have not yet come to the to reality. Because it's not that easy. It is very easy to talk about, but very difficult to implement. Because even there are, say for example, many genetic diseases like diabetes and other things, they can be checked at the gene level itself before the offspring is born. There itself they do a correction, gene correction that is going on, but still not very successful. They are in progress. So that is one aspect. And artificial intelligence, machine learning, these are all talked about nowadays, and that anything can be done. That still a human element is very important in all these things, because machines cannot speak, or whatever you feed, that only it will be able to. It doesn't have intelligence on its own. So there is always a human element in this. And it is very important that nothing can beat a human brain. That is why but human beings are using only 25% of their intelligence in general. There is a survey. But if you improve it further, that itself is good enough. You can turn out maximum from human beings. Whereas in the artificial intelligence and machine learning, these things are, the fact that it is artificial intelligence shows that it is not a real intelligence. It is something has been fed to make it intelligent. So, the fundamental difference, I come back to the academicians, that they do fundamental research with no industry connect. But nowadays, all the good universities, they have collaboration with industry. It is not only for getting funding, but also whatever they produce should be useful to the common man. Because our poverty levels are so high, and there should be some media by which they get the benefit. That should be that is the motto of the Indian government also. Whatever you do, whether it reaches the common man, is important. And nowadays, anything that you talk about, they are relating it to the human beings. So it is very important, and in the purely academic institutions, they go by publications. That is probably because the judgment by which the promotions are given, they are based on the publications. Whereas in industry, we focus on patents. And patent is again a publication which involves a lot of money. It is not free like in journals. So it costs money. If you want to take patents in different countries, it is, I am talking about in 1982, it was $60,000 US. Now I don't know, it may be much more. So because you have to cover it throughout the world, in case it becomes a drug, or in case it becomes very useful, you can get benefit from by way of royalty. So it is extremely important that you should have usable patents, because it is not a substitute for just a publication. Then it is expensive, but it should be usable. Number of usable patents you should have. Either they should be able to monetize the contents of the patent, or at least it should prevent other people from using that methodology. These two should serve. And the patent should have novelty. First thing is novelty and utility. These are the two main criteria by which a patent is granted. And the novelty does not mean it should be a very complicated compound. It shows that it does not have any prior art in literature. That's what it means. Nobody has made that compound. And the utility is very important in granting of patents. So these two are important. No prior art in literature, and it should have utility. These are the two main things. And the patent validity, as you know, the international patents are 20 years it is valid from the date in which it is applied. So in industry, most of the people talk about patents because it is judged by the number of patents you have. And again, if you were just for the sake of filing, if you increase the number, then there will be a question of usable patents. What does it do? Whether it has any utility. That is ultimately very important. Because filing a patent anybody can do. 5,000 rupees anybody can get an Indian patent. But that's not the point. But it should have utility is very important. That we ourselves have to judge whether it is useful. So that is one difference. And that's maybe in industry they don't, based on publications are dissuaded majorly, but whereas patenting is encouraged. And the patenting again is usable patents. It should have utility at some point, whether it should do something new or it should prevent the competitors from doing it. So this is one of the main differences. But the funding, the academicians depend on the external agencies to fund, whereas in industry they do focused funding. They will do only of interest to them, which they can monetize. Only those things they will allow you to patent. Publication in multinational companies is possible only after taking patenting. First protect the patent and then you can publish it. After a year you can publish it. So you get both the benefits, publication and patents. So nowadays the number of patents have increased. Even in India, the many people do patenting. And it's a third thing that which is focused on in the industry is they will do only things which can be exploitable and sold. Whereas that commercial angle is lacking in academic institutions. And another thing is in United States, all the universities, they will have collaboration with corresponding industry. Say for example, Harvard University, that professor will have interaction with Pfizer, big multinational companies. They will here it is taken as a way of getting additional salary or additional funding, personal funding, and also if they want to go abroad to make a presentation, then they will look for industry to sponsor the trip. Only for these things it is used, whereas it is not the case in industry. So industries fund, they have focused funding. They will not waste money unnecessarily. Unless there is some potential, atom of potential, they will not venture into it. So that is another major difference between academia and industry. But in institutes like CSIR laboratories, they were mainly instituted for small scale industries to flourish in that region. For example, previously they used to be regional research laboratories. The IICT used to be Regional Research Laboratory Hyderabad, and NIST Trivandrum was Regional Research Laboratory Trivandrum. They were all regional centers. Now, to focus on what they are really doing, they have changed the name to Indian Institute of Chemical Technology to show that they are doing mostly developing technology, both science and technology together. That is why it is called Indian Institute of Chemical Technology. It is chemistry based and technology oriented. Anything without any science which cannot be utilized and converted to technology is not of much use. Like suppose you have an idea and you do that and you have been successful, but no utility for it. That idea will die as it is. It cannot be published, it cannot be done anything, nobody will look after. So there should be a commercial utility should be there for every idea. So that is important in industry. So these are some of the main differences between industry and academia. But academia is equally important because they have sky is the limit, they can work on any project and they can, suppose industry gives a small problem to be addressed, they will be able to do it, and to that extent they will get consultancy and they will get monetary benefit. But that cannot be taken as a right that you will be a permanent consultant. As long as you do well for their project, they will be kept, otherwise they will go to some other consultant. Just like a business only, unless there is some benefit, nobody will utilize. The only thing is the IITs, for example, IITs are the best institutions, ISIRs and IITs in India, and they all have very high collaboration with the industry. Say for example, if it is a leather industry, leather technology people always have collaboration with CSIR-CSMCRI. And similarly, people from UDCT in Bombay, they have collaboration with CSIR-CSMCRI. So majority of people, they are specialized institutes, they have collaboration with the specialists. So this is a very important aspect in this. CSIR has been working very effectively on this area of collaboration, and they have been extremely successful. So it is for the scientists to make it successful, because there is no shortcut in this. You have to increase the visibility of the institute by publishing in high impact journals to start with. Then you should have collaboration with the industry to have patents and then usable patents. All these things are jobs of scientists of national laboratory. And another thing is, to start with, everybody, they don't, intelligent people are not born, but they are made. Because you cannot say that we are not getting good people around. But you have to, a good teacher has to inspire and make say 100% results, means they should produce mediocre people and make them artisans. That is the job of a good teacher. Because you cannot take a salary and then take all bright people and show that we are getting 100% result. That is not correct actually. So you should take mediocre students and make them good. So that is where the inspiration of teachers, that is extremely important. And another thing, main difference between industry and academia is that the industries, they work only, the industries work on projects which have wide applications. Whereas in academicians, they work on a very broad project, which somebody has to see that by publishing in high impact journal, they have to come to know, and then based on that they will come back to the academic people who published it and all, then they get contacts and they do like that. Whereas it should be a routine affair, you should always do applied work, and that is finally will yield the fruit. So what I am enforcing is imposing on you is that people should have a good reading culture. Whatever literature, whatever expertise you have, you should be up to date in literature. You should always be using the library to your benefit and read what others are doing first. That is very important before you do on your own. Otherwise, unnecessarily, whatever you have done, it would have already been done by somebody. There would be prior art in literature. So kindly cultivate the habit of reading, extensive reading in new topics, and attend lectures and learn from them and apply them to your research and come out with something very useful, and in whatever is focused by the institute. Once you have taken that institute as your institution, then you should work for the benefit of the institution only. You should bring visibility to the institute. By itself you will be prospering. So with this I wish all of you a great success, and at the end of this seminar, probably at the end of this function, you should also be thankful to God that the forefathers have generated this institute and given it to you on a platter, which you are enjoying, and at the same time you should do something for the institute also, that you should keep it in mind. Thank you very much.
धन्यवाद डॉक्टर गोपालन। कार्यक्रम को आगे बढ़ाते हुए अब मैं समारोह के मुख्य अतिथि एवं वक्ता श्री नीलेश एम देसाई का परिचय प्रस्तुत करना चाहूंगी। श्री देसाई जनवरी 2021 से स्पेस एप्लीकेशन सेंटर इसरो के निदेशक पद पर कार्यरत हैं। वे एलडी कॉलेज ऑफ इंजीनियरिंग गुजरात यूनिवर्सिटी के 1986 बीई इलेक्ट्रॉनिक्स एंड कम्युनिकेशन बैच के गोल्ड मेडलिस्ट रहे हैं। लगभग 37 वर्षों के समर्पित व उत्कृष्ट इंजीनियरिंग एवं रिसर्च करियर में उन्होंने इसरो में माइक्रोवेव रडार, रीसेट, ओशनसेट एवं निसार की रचना एवं विकास के साथ साथ अर्थ ऑब्जर्वेशन, नेविगेशन एवं कम्युनिकेशन की उन्नत तकनीकियों को समाज, शासनिक एवं स्ट्रैटेजिक उपयोग की ओर अग्रसर करने में महत्वपूर्ण भूमिका निभाई है। वे वर्तमान में रिमोट सेंसिंग डाटा प्रोसेसिंग, सेटकॉम टर्मिनल एंड ग्राउंड सेगमेंट फॉर मोबाइल, ब्रॉडबैंड और हाई थ्रूपुट कम्युनिकेशन सैटेलाइट के साथ साथ क्वांटम फ्रंटियर्स, आर्टिफिशियल इंटेलिजेंस, मशीन लर्निंग जैसी उन्नत तकनीकियों से संबंधित गतिविधियों का भी मार्गदर्शन कर रहे हैं। श्री देसाई ने अनेक वैश्विक एवं इंटरनेशनल कमिटी ऑन ग्लोबल नेविगेशन सैटेलाइट सिस्टम (आईसीजी) बैठकों में इसरो एवं भारत का प्रतिनिधित्व किया। उन्हें इसरो इंडिविजुअल मेरिट अवार्ड 2010, इसरो टीम अवार्ड रीसेट 2012 एवं इसरो परफॉर्मेंस एक्सीलेंस अवार्ड 2018 से भी सम्मानित किया गया। इस संक्षिप्त परिचय के साथ अब मैं श्री नीलेश एम देसाई को CSMCRI स्थापना दिवस व्याख्यान फाउंडेशन डे एड्रेस के लिए आमंत्रित करती हूँ। व्याख्यान का शीर्षक है सैट इसरोज एंडेवर्स ऑन ग्लोबल साइंस। सर, आपका स्वागत है।
Good evening. At the outset, let me thank the organizers, Dr. Kannan Sahab, and all the other organizing team members for inviting me here for this important event for all of you. So let me congratulate all of you. आप सबको बहुत बहुत शुभकामनाएं आपके 70वें फाउंडेशन डे पर। आई थिंक हिंदी में बोलना जरूरी है सेंट्रल ऑर्गेनाइजेशन में। सो बहुत बहुत आभार आप सबको। गुजरात में तो गुजराती भी बोलना चाहिए। So my endeavor, in fact, I was the only patient among all the doctors here, and many of you are also doctors. So I am a hardcore technologist. So in that sense, I am a misfit here, addressing all of you who are core scientists. And Dr. Gopalan Sahab has very nicely put up all the aspects of industry, academia, and all the related research institutes like yours. So we call it triad. in our sense. We have a research, CSIR is also a research institute, of course, related to space technology and space science. And we have a triad combination, now it will become quad. Triad is research institute, academia, industry. That interface we try to promote so that everything goes on very smoothly. And of course, nothing is complete without policymakers. We can call it, there may be a hindrance also, but many times they are required. They should be actually regulators or facilitators. But anyway, their role is going to be there, but government wants that now their role becomes minimal so that the other three can prosper. And of course, this government wants that industry participates in a big way in many of the research aspects also. And you must have heard about space reforms also recent years, because space was a very closed domain. And today I am not here to, it is your foundation day. In fact, incidentally, we also completed our 50 years in December 2022. So that way we are younger than you people. So don't go by that science is always wrong, it never solves a problem without creating 10 more. That is George Bernard's way of telling things in a proper perspective. In fact, he said that, generally we say that better late than never, isn't it? So we were late today for your function, sorry for that. But he used to say that better never than late, because then at least your reputation will be intact. If you don't go to a function late, so he may be stuck up somewhere or he's busy, very busy person, so he didn't come. Anyway, so what my attempt today is, in view of your foundation day, and there had been earlier collaboration between ISRO and your institute long back. That was what I was told. So since I got this opportunity to visit you people, so we thought that this collaboration or cooperation should be revived. That is what is our wish. And hopefully, so we'll try to tell you about what we are doing, which can directly feed into some of your activities, whether it is research or whether it is application of some of the aspects which we do. And we do a lot of funding for various collaborative projects, especially to research institute like yours or academia, and we can have a joint work also with academia. So there are many possibilities. So just we'll try to highlight some of those aspects so that if something drives you towards or motivates you to take up some activity, it will help cause of everybody. And what below what you are seeing, fishery, coastal zone management, snow, glacier, wetlands especially, similarly ocean state and all that, maybe some of the topics related to that may directly be of interest to many of you. So that is the idea behind this lecture. When I was told that you have one talk on that, so I thought let me put ISRO some of the activities and then some of the activity which we do related to ocean, which may directly feed into our collaborative work. So we do everything that you can think of in science and technology. Next. Incidentally, we have a common minister, Jitendra Singh. So, this is our vision. All of you are well aware of Dr. Sarabai, who was incidentally a Gujarati, belonged to the place where we belong, that is Ahmedabad. And he gave that vision. He used to sit in Physical Research Laboratory, which is again a very well-known institute, as we are aware of. And he said that we want to use space or space research and technology. We are more a technology institute, but we do a lot of science application of the things also, which will directly help you to understand. So he said that we want to use space research and technology to solve the problems of common man in society. So with that aim, we started our India space program almost 53 years back. And what he said after that, I have hidden that, because what he said that next sentence was, we are not here to compete with developed countries or advanced countries to go to moon or Mars or to put man in space. Today we are doing exactly that. We are going to moon, we are going to Mars, we are doing Gaganyaan, which is putting man in space. So in that sense, it will appear that whatever he said, please don't do that, that only we are doing. but it is not like that. We are doing that also because that is the need of the hour. India aspires to be a superpower, if not a world power, at least a regional power. So all these things are also necessary to acquire technology, because these are the technologies which nobody gives you. As many of you would have realized, many things are denied to us. So we have to do it in our own ingenious way. Of course, Sarabhai died very early. You may be aware, 52 years age he died, 1919 to 71. And then Professor Satish Dhawan took over. He was a hardcore technologist like me, came from USA after finishing his doctorate, I think. He was a mechanical engineer. And he was director of IISc when he came from USA. He was appointed director of IISc, Indian Institute of Science in Bangalore. So when Indira Gandhi told him to take over ISRO, he said that he's willing to do that, but he doesn't want to leave academics. So the solution was ISRO was brought from PRL, or its headquarters in Ahmedabad to, it got shifted to Bangalore. So that was our loss. So we still lament that decision. But of course, that was the need of the hour, because Satish Dhawan was a very able successor. He steered India's space program for another 13 years after that. And that's why our headquarters, if some of you are aware of, it is exactly opposite IISc in Bangalore. So that was the reason, because Dhawan used to handle both the institutes. And Kalam, anyway, all of you know about him. He was our rocket man. He started many rocket activities. And incidentally, his tenure in ISRO was not that great success, because these were beginning years, and his programs, the SLV or ESLV, the initial rocket programs were not that successful. More failures were there rather than success. So in that sense, he was not a very successful rocket man. Then he moved to atomic energy, then DRDO, then he became advisor to Defense Minister, then Prime Minister, and of course he became President of the country. So there was something in him. All of you, we know that. He was a great motivating person, a great leader, who could motivate people, who could inspire all the young children, students, or scientists also. And that way he rose to the highest post of this country, that is presidency. And then another person we are seeing here, Professor Yashpal. He was in TIFR as a social scientist. He was brought to Ahmedabad as our first director. We were scattered all the places in Ahmedabad, that was brought under one umbrella, and Space Application Center, my center, was created. He was our first director. He used to be in TIFR. He was appointed our director. I am the 13th one, so 13 is a lucky number for me. And here you see a rare picture of Dr. Sarabhai with Kalam discussing something in Trivandrum. So this is our brief history, and this is where our space program started, as I was mentioning, PRL. But before that, Sarabhai used to work from his house here, Retreat. And then PRL was, then he took some labs in one college called MG Science Institute in Gujarat University. So initially he set up his space related laboratories in this MG Science. So he worked almost for 7 years there. And then Jawaharlal Nehru or C.V. Raman laid the foundation of PRL building. And after that, when building was built up in 54, Jawaharlal Nehru came there to inaugurate. So that was the brief history of PRL, where our space program started. And this is how we started, because as I said, our emphasis was on applications. All the time space program wanted to do something for the man, for the common man, for the society. So that was the motto. So first thing, and finally we wanted to build our own satellites. So it started with Genesis is applications. So we thought that first we should know how to use a satellite rather than building satellites. So that's how this American satellite was hired, ATS-6, and we carried out this experiment of beaming a TV broadcast. A TV signal was sent through satellite all across the country. Today you can watch TV on your mobile also. So you will say, what is so great in that? The great part was 2,400 remote rural villages in 75, when even electricity was not there. They were mobilized to do this experiment. So that was the great part of that. And then since we wanted to build satellites, so we again hired a Franco-German satellite, Symphony, and that was used to carry the experiment of communication. Today, sitting in your home, you can talk with anybody in the world. This is how satellite was used to do the two-way communication. So that is how we learn how to use satellite to do communication. So these were our initial days. This is ISRO. Most of you are aware of that. We worked under Prime Minister. Atomic Energy and Space Act worked directly under Prime Minister because many of our proposals needs urgent attention. So that way it is easier to go through by bypassing various bureaucracy. That is the only way we can get approvals fast. Otherwise it will take its own time. And the Space Commission is the guiding body, Department of Space. And now you have heard about space opening up. We have a commercial arm called Antrix, and now New Space India Limited is the public sector company which is set up. And we have another regulator, which is what I was talking about, Indian National Space Promotion and Authorization Center. So this will work as a regulator or a facilitator. We have developed a lot of infrastructure all across the country. So now government wants the private sector should also utilize these facilities. So finally, after all, they are built with public money. So public should have access to that. Otherwise, if you pass through ISRO, nobody will allow you to enter the campus also. So to take care of all these aspects, now this InSpace has been set up. You can, academia or research institute or private industry can apply through InSpace, whatever they want to do in space, and utilize our services in whichever way you want. Consultancy, simulation, designs, or using our facilities, or whichever way. Even if private sector has got orders from foreign countries, they can still use that to leverage, to work using our facilities. So that all combinations are possible. They have to go through this in space, and once they scrutinize the proposals, we will act on that. And this is ISRO, various places all across the country. SAT is one of them. We are one of the 7 big centers, and we have something different. How I will come to that. And each place has its own ambience, whether it is Bangalore, Trivandrum, Hyderabad, Dehradun, many places. So I invite any of you who are coming to Ahmedabad, please do visit us. We will facilitate your visit. And ISRO's one unique point, till now we used to harp on that, is that everything under one umbrella. We do everything which any space agency can think of. All the other places in USA or Europe, or now they have segregated many of the aspects. They have left it to private sector, many things academia do. Unlike that, we used to do everything under one umbrella. So that now we want to dismantle to good extent, so that all activities can be taken up in different sectors. This is our record. As I said, 53 years, looks very impressive or satisfactory at least. But what is not coming out is that failure is part of our success. So we have as many failures as it appears a successful scorecard. So we have many failures in rockets, in satellites, in payloads, many things, in experiments. And this is the latest launch vehicle. The second flight we just completed in February. Before that, last year in August, we had this first flight, and that was a failure. Although it is a derivative satellite or launch vehicle, still it failed. So what I am trying to convey is that failure is part of our whole business. But overall, it is a very successful record as far as ISRO is concerned. And this is my place, Ahmedabad Space Application Center, Antrix Upyog Kendra, Ahmedabad. And this was the only building in that whole area. If some of you have seen Ahmedabad satellite area, it is considered to be one of the costliest area in Ahmedabad today. But those days when Sarabhai started the whole program, this was the only building. This was India's first Earth station. Earth station is a place which from where you can communicate with the satellite. So satellite signal come to this place, and this was the first antenna which was built in the country, 14-meter diameter. It was built by NEC Japan, Nippon Electric Company, Japan. They built it. And as I said, this was the only building in the whole area, otherwise it was all a forest area. And now we have, at this place itself, we have 50 buildings. And 2 more campuses have come up 7 kilometers away from our satellite area, which is near Bhopal, satellite suburb of Ahmedabad. So we have 2 more campuses there. We have very good exhibition, and each space is housed here in one of our campuses, through which academia, institute or private sector can work through. And we have one Earth station again in Delhi. Again, this has its historic significance because Indira Gandhi used to go to this place to address the whole country. Those days, in late 70s, early 80s, Prime Minister also has to go to one place to address the whole country. Unlike today, you can do VC, video conferencing, anything from your mobile, sitting at your home or your office. So unlike that, this was the times when this Earth station was set up for that purpose. And now SAC, I told you that it is a unique place compared to other ISRO centers. It is multidisciplinary, and we do what we call the heart of the satellite, payload or NITBAR. So the payload is the one, camera or radar or many other sensors which do the actual work, which is the heart or the brain of the satellite, and the final end product, applications, which many of the research you people also do, that how to apply it for actual activity, final activity. So that end product or application or upyog, that also is done in our place. So we do the starting point as well as the end point of any satellite mission. So that way we are unique. So to do this activity, we have hardcore technologists like me, electronics engineer or mechanical engineer, computer scientist, computer engineers, or scientists like you people, those with science background and different levels of backgrounds, whether it is biological science, physical science, chemical science, geoscience, marine biology, many things. So all expertise which you can think of in science, those people are available with us. We have strength of 2,000 regular employees and another 1,500 on contract. So you can imagine, so the atmosphere is very lively. It is like an academic institute, a university, where you find all type of people. So something similar exists in my center, where we do this research or technology development. And as you can see, to do this endpoint, starting point and end point, it will involve most of the things you can think of, whether it is software, data processing, signal processing, or science related to that, or even social scientists are also required to get feedback for our programs. So we have a social research unit which gets us very important feedback on our space program, whether we are going in the right direction or it needs some course correction. And we have partnership with almost everybody you can think of, industries, SME, MSME, research institute, academic institutes, and of course international space agencies as well. This is how we are arranged. So we do camera systems, radar systems, then various science and applications. So we have people or the areas or entities are arranged in that fashion. We do a lot of hardware development and antenna optics, they are the front end. Now we have Gaganyaan program, so human space flight related aspects, then applications, data processing, and then support staff related to electronics fabrication, mechanical fabrication. Reliability is a very important element in anything you do. It has to be first time right. It should work once you design, conceive, simulate and use it. If it doesn't work, that is a failure. So, and of course planning and all these are part of any mission. So all activities you can think of in umbrella, under umbrella, that we do at SAC. And as far as science and applications, so what we do is that we get the user requirements, do the definition of how we conceive a project. That is what is shown. So science is part of all our conceptualization of any mission. Then we try to define or design the sensor. Then we finally, that simulations happen, then product generation, and then demonstrating the application part of it. So all these three activities involve a lot of science. So this is how science and application activity happen at our place. So lot many stakeholders, whether it is ministries, state departments, and institute like yours, take part in that. Now coming briefly to what activity we do, that is remote sensing payloads where we have camera systems and radar systems. So this, we work in all frequency bands. So there is science involved for each frequency band. Why particular frequency is chosen to do some application or science? So there is also a reason behind that. So all this we try to assimilate before defining any mission. So we have now mission related to land and water cartography, especially which will be of interest to you is oceanography. So we have dedicated mission for studying oceans only. Scientific space science, meteorological observation for weather prediction, climate change, all these things, and different type of camera systems related to it. So these are our missions. So I don't have to elaborate on that. We have all type of missions which you can think of for land applications, for ocean application, for weather, climate, or many other aspects related to security, strategic applications, many things. And we have moved from, as you can see from here, earlier our images were 1 kilometer size, means your whole campus will appear as one dot in an image. So you cannot make out anything out of that. Today I can have an image of 1 feet, 0.3 meters. Means I can know which car is parked where in your campus. So that much the technology has improved. So this is how our progression, and in size, miniatures, and how electronics has improved, or technology has improved over these years, 40, 45, 50 years. This is the progress, and that is correspondingly reflected in the images we generate from a camera system. So these are some of our latest systems which we have developed, and Ocean's satellite, OCM3 or OceanSat 3, that is the last one we launched in November. This is one image of a satellite which is a nano satellite or nano camera system which we developed specifically for our neighboring country Bhutan. The Prime Minister wanted that we should help our neighbors also. So Bhutan being our immediate neighbor, and they wanted something which images their area in a repeated way. So this was first image generated for that particular satellite. Now that satellite we have dedicated to Bhutan. We have set up our station there, so they will receive their data and process it. We have taught them how to make satellite, how to do processing, many things. And this is our radar program. So like camera, radar can also take image. Radar have strategic usage. Similarly, they have applications related to remote sensing and many science applications related to ocean also. So this is how our radar program has moved. Again, here also from few hundreds of meter to 1 feet. That sort of images you can generate from a radar system. So this is how various types of radar. And radar, another problem is it is a very costly affair because camera systems, optical system depend on sunlight as source of illumination. While unlike that, radar has to carry their own transmitter. So that's why cost increases. And then its processing part, you need to do a lot of signal processing. Some of you are aware about processing aspect. So it will need supercomputers to do processing. So these are another area where we have now acquired expertise. India is a world leader in this radar development. And these are some of the recent radars we have developed in last 5 to 10 years. So they take care of all the interest, not only scientific interest, but the strategic interest of the country as well. So this is one typical land application radar, ARAI Set 1A, which works in C-band, 5.3 gigahertz. So it has many applications. It is one frequency band which has application in ocean also, land also, cartography also, many things. So these images you can do decomposition, polarization. It gives signals in various polarizations. So that will give you a lot of information. So some of you who are experts in science, they can understand the importance of using different wavelengths of different polarization for doing scientific studies. And this is one dedicatedly satellite we are building for maritime applications. So which will be of interest to some of you, because this data will be available to the users or to the researchers, which can be utilized to do many applications related to oceans. So this is one area. Of course, it has many strategic applications. It can detect ships of various sizes, because now ocean economy or blue economy, of course, they are two different terms, but that is going to be very important in overall strategic angle point of view, because China is going in a big way surrounding us from all aspects. So India has to match up to the challenge posed by China. Similarly, once the data is available from satellite, it has to undergo a lot of processing. So you need supercomputers or high-end computers or different type of embedded processors and other things to do various type of processing. So this shows in a nutshell what different type of processing we do to get information out of the data. So that is the essence of this activity. Like this example of tsunami. So we have a pre-tsunami image which was taken almost 2 years before the tsunami happened, and that was compared with when actually tsunami happened in Chennai. So immediately after tsunami, we captured this image and tried to correlate these two images to find out the extent of damage. So these are one of the applications. So like that, there are thousands of applications in different domains to use satellite data from remotely. This is till our radar satellite was launched. You cannot take images of Himalayas because it is always under cloud cover or rains are there. So in that condition, optical camera will not give you good images. Like a normal camera, if focus is not proper or cloud is there, you don't get good images. So something similar happens in camera systems from satellite also. So their radars only are the useful tools to do the imaging. So this was the picture of Himalayas using radar. So similarly, various application, oil spill detection, and various application of polarimetry, what I was mentioning. So wavelengths and this polarization is utilized to derive different types of information from each of the images. So this is again an area of research. This is a typical strategic important image of various strategic points. It is like Shanghai airport of China. So our satellites are regularly imaging different parts of the world. One of them is China. So it is not that America, Russia and China only can spy on us. We are equally competent to take care of our interest. So this is how this airport of Shanghai, we can do in very minute. Why both are needed? Somebody will ask if camera images are there or radar images there, you do use only one of them. This shows the utility, how synergy can help us, data fusion. Here is a camera image where you see a lot of white spots. So they are actually cloud cover. If cloud is there, you don't get images from a camera system. So their radar, this is a radar image. So you can see here there are no white patches because radar can penetrate, radar signals, microwave signals can penetrate through any cloud, rain, anything. So that is the advantage of using radar. So both together, because camera picture will give you very good clarity if good sunlight is there. So this is the work. So like this, many opportunities are there to do different type of research activity. And earlier, satellite used to give us raw data, then you do processing on ground using supercomputers or high performance computing machine or GPUs and all these. Now trend is then it becomes, so you generate data products out of raw data, and from that data you try to derive information. This is the work of scientists. But now the trend is towards what we call ARD, analysis ready data. Many of you have heard about this term. The directly satellite will give you data in such a form that you have to just apply your other algorithm to get the information out of that. So it is ready for analysis. And now trend is towards what sir was talking, and you mentioned about somebody talking in the morning, AI, ML, deep learning, all these things. So it has to be AI ready data. So data will come in such a form that directly you apply your AI, ML algorithms to derive information. So that way it eases the task of the final application scientist like you people. So this is how the trend now in the world. And likewise we do various applications from whatever data we generate. We do earth observation, and earth includes ocean also. Earth is a broader term. So whether it is agriculture, forestry, atmosphere, marine ecology, or many all associated oceanography, water resources of the country, urban mapping, and cyclone monitoring, disaster support, all these things. And the final aim is to have a sustainable development, disaster management system, governance, because all this still feeds into the governing system of the country, Niti Aayog or Planning Commission, all these things. So they take the inputs, do preemptive measures, that like we are hearing this wheat crop, there was a conjecture that wheat production will decrease because the heat wave and all. But now it has been derived that it will affect by only 1% or so. So all this information will come from in advance through such remotely sensed data. And of course the direct benefit, all of you know, earlier cyclone, people used to die like anything in our country. In the 1970s, 5 lakh people died in that cyclone which affected Bangladesh and India. Today hardly any people die, 20, 25, 5, 6. That also should not die. Our attempt is that our system should be robust enough. In USA you must have seen regularly tornadoes or typhoons and all these things come, but people don't die. Of course there's damage to property and all those things. So we are striving towards that. This small number of people also should not die. So we took preemptive measure because we know how cyclone is generated. At the point where it is generated, it is called cyclogenesis. So we understand its origin and it is tracked continuously till there is a landfall. So all these aspects also are taken care with the help of satellite data. And of course, some of these things will interest you. How we use data for agriculture or environment monitoring, various aspects related to mangroves, corals, wetland mapping, where some of you are involved. So all these activity, our satellites feed into these activities. So here are the areas where we can do joint activities. Some of you are interested. Similarly, water conservation, hydrology, ocean, blue economy. Ocean economy, of course, using ocean resources. But our attempt should be to use it in such a sustainable way. So like green economy, there is a blue economy. So that they are exploited in a limited way so that it doesn't affect the overall environment also. So coastal zone management, navigation, potential fishing zone for food security, because fisheries is a very important element in food chain. So all these aspects are being addressed using these ocean or blue economy related satellites which we built up. And of course weather, I have already talked, energy, finding out new fuels, whether it is biofuel also is part of that, wind energy, solar energy, wave energy, all these aspects. And of course urban area, because we live in cities, it is predicted that almost 70-80% of our population will shift to cities in due course. So all these things we have to do urban mapping in a big way so that smart cities are generated. So all those aspects also our satellites give you a lot of information which can be utilized to build better cities. This is one Prime Minister announced it in Glasgow, COP26 meeting last year, that we have made a solar calculator. So that gives, it is a Android app which you can download on your mobile and use it to find out where you can set up these solar energy farms so that electricity can be generated. Using satellite data, we give you information that every month or every day how much energy will be generated. So all those aspects, where to set up that energy farm, big farms. Even in your rooftop also, which house will give you better energy, all those aspects also you can work out using this small app. So we did it for India using our INSAT 3D satellite data. Then he announced that we will do it, of course we have done it for Africa also, because International Solar Alliance has given us this task. Then he announced that we will do it free of cost for the whole world. So that was what activity we took up last year, and we have now completed that solar calculator. So it is available on our website. Anybody can download and it will give you information, all these aspects, so that where to set up a power plant related to solar energy farm, which will be ideally located, you can feed your energy directly into the grid. All those aspects it takes care and give you the right information. And similarly, total geospatial energy is a very crucial information for a country. Whatever energy is generated on a given day in a whole country, and where you want to shut down thermal plants because wind energy or wave energy or solar energy is sufficiently generated. So accordingly, in real time, you can take decision based on this. So Niti Aayog told us to develop this particular geospatial energy map of India. So all resources from various ministries, they were collected at one place and we could do this exercise. So that now, of course, this data is not available to everybody because this is very critical data for a country. Because first thing any enemy will attack is your power lines. When war happens, they try to destroy your electricity setup so that you are crippled. So to take care of all these aspects, and especially from environment point of view, this has very utility, because based on this, in real time, government takes decision which thermal plant to operate today, which to shut down, because sufficient energy is generated from renewable sources. So all these aspects are going to be very critical in future. And similarly, this one other major exercise government wanted was agriculture. Because of this Kisan Andolan and all that you have seen, government wants to do something for farmers. So this is a agri decision support system. So crop insurance related claims of farmers, whether they are right claims or not. So all these aspects are taken care of by getting all the information. So like that energy map, all information related to agriculture from various sources in the country will come at one place, and based on that various decisions are taken. So here I don't know whether your work area also fits into those activity. You can try to explore that, but this is going to be a very important element in India's decision making. So for your perspective, so these are the areas where we can collaborate, whether related to ocean hazard, fishery, tourism, blue economy, which are these pillars, ocean energy and navigation. So any of these aspects, if some of you are working on those aspects at your institute, at your other sister organization also, you can let them know, and we can have collaborative work, and we try to do work together. We can provide you data, we can provide you guidance, and we can take guidance from you about applications and many other aspects. So this was the satellite we built. We have a OceanSat series of satellites. Last 30 years we are working on that. So we have OceanSat 1, 2 and now 3, which was launched on 26 November. It has contained this microwave and radar as well as camera payloads. So OCM3 is a ocean color monitor, which gives you information about chlorophyll, phytoplankton and all those things, which can directly feed into various applications. And similarly, spectrometer gives you the cyclogenesis. So information about the wind vector, because getting information about the vector is very difficult. Wind speed anybody will give you, but wind direction nobody can give you. So all these aspects are taken care of by this instrument called wind spectrometer, and there is a sea surface temperature monitor, SST monitor. So this is another area. So this satellite is going to work for minimum 5 years to 10 years. So, and then we have planned OceanSat follow-on series also of after 3. So these are the various activities where if some of you are interested, we can work further on that. We have what we call OceanSat 3 utilization program. So recently we had a workshop for that. I don't know whether anybody from your side participated into that, because we called many research institute from Ministry of Earth Sciences, but I think we forgot you people. But we can take it up in future. So this is a typical ocean color monitor image, which can be utilized to do various applications. Similarly, this spectrometer radar, which gave same satellite, it gives you information. Immediately this Mendes cyclone came. After we launched it on 26 November, I think around December 1st week, this cyclone was there in the Indian region, and it was captured very well. So these are the various applications where if some of you have interest, you can take up all these activity related to ocean state, whether it is for maritime navigation or for potential fishing zones related to fisheries, related food security aspect, then ocean energy, monitoring various ocean hazards. Similarly, for tourism, what all aspects are important, rip currents, because they are the major source of disasters where people go for swimming and they get drowned. So these are all the technologies we have available. You can work out on the various opportunities. Out of that, any application problem you can take up, come to us and we can jointly work on that, or we can provide funding related to that. And using geospatial, because now trend is towards using geoinformatics everywhere. So I hope that some of you try out that aspect also, because everything is going digital. So it's a part of digital economy, and especially related to energy, solar, wind, wave, bio. So I think all these three affect some of the activity which some of you may be doing related to biofuels or having various sources of energy, because this is going to be a big source as far as renewable energies are concerned, related to especially bioenergy where many of the algae or many other studies which some of you may be interested in can take up. So these are some of the images which from the satellite, how these images come from our satellite, and how you can now, you have to see now how you can utilize it for various applications related to. These are two websites related to oceanography and meteorological data, and one is related to earth observation land application data, where many dual use technologies are also there, which are usable for both land and ocean or coastal region. So all this, you can have a look at this website, many applications, many test cases or case studies are also mentioned there. So based on that, you can derive any new information or new application out of that. It will give you idea. This is one program I just wanted to mention, NASA ISRO radar. Generally NASA doesn't cooperate or try to collaborate with any other space agency because of course they are number one in the world. Similarly JPL, Jet Propulsion Laboratory in California, some of you heard name about that. It is considered to be world's best aerospace laboratory. So when we launched our first radar satellite in 2012, after that they came to us, they came to India, NASA and JPL, and they proposed that they have a very patented technology called SIR. We have done SAR, synthetic aperture radar, if some of you are aware of that. So they have this patented technology called SIR. So they wanted this SIR to be launched by ISRO. So they will bring that radar, which is the, as I said, heart of any satellite is the payload, which is radar. So SIR they will bring, and they wanted our satellite and launch vehicle to launch that rocket. But you will be surprised that NASA is number one space agency in the world. JPL is number one aerospace laboratory in the world. We are nowhere compared to them. But we said no to them, that we don't want to collaborate. The reason was, it was not that we were great people, because we were not gaining anything out of that. Because we were just like a service provider. If somebody comes, you take me to airport or railway station. So it is like providing services. So we were not gaining intellectually or technically out of that collaboration. That collaboration doesn't have any much importance for anybody. Any collaboration has to be mutually beneficial, isn't it? So then we discussed, negotiated, lot of things happened for next couple of years. And finally we decided that they will make one radar, L-band radar, L-band frequency, and we will make S-band radar, same technology. So that helped us to do a lot of collaboration. Our people went there, their people came to us, and we developed everything jointly. And then, of course, the work was done independently. They developed their radar, we developed our radar. But many compatibility issues, interfaces, many things were discussed. And in the process, we learned, they also learned how Indians do this Jugaad Paddhati, all these things. So it was a mutually beneficial collaboration, and the payload is ready. It is the last February 2023. It was brought back. So we developed our radars, S-band, and sent it to JPL in California. It was integrated with their radar. And finally, this is what you are seeing is our radar, which we developed. This housing is given by them. So they send the mechanical housing to us. We mounted our radar into that, did the testing, and then sent it back to JPL. They integrated their radar. Of course, they occupied the prime space in that box, because of course it was their box. So we had faced a lot of technical difficulties, and finally these are all the applications, which include some of the ocean application also. And this data is going to be available free of cost. So that's why all researchers who are interested in doing some research using this radar, it is going, the whole world is looking forward to this radar, because it's the first time such technology is going to be in space, and that too two radars at the same time, simultaneously observing a place. So that has its own connotations. So now it has come back to our Bangalore center. It is getting integrated with our satellite, and then it will be taken to Sriharikota for the launch, final launch, which is going to happen on January 29th next year, 2024. So watch out for that date. These are all the application. Coast and ocean is one of them. So I will urge all of you to keenly watch this if it is of utility in any sense. L and S band are considered to be very important frequencies for such applications. So, and it has one major other application is land deformation, because till now it is not possible to predict earthquakes. Earthquake may happen, but afterwards everybody is wise that there were precursor and all those, many papers come. But beforehand prediction of earthquake is almost impossible as of today. So we hope that something comes out of this mission which helps us to get some precursor or some prediction. And of course coast and ocean, so this, watch out for this. Data is free of cost, so we will get a lot of things. Many other things also we do, communication satellites, navigation satellite, but I will not bore you with that. Just one thing I wanted to mention, why communication is important, satellites. Because till now we have been doing satellites, communication satellites, which are geostationary. All of you would have learnt about that Arthur Clarke told almost 60 years back that 3 satellites can cover whole world for communication. And if one satellite is there, it covers 1/3 of the globe. Now the trend is towards what you are saying, Leo constellation. That was geostationary, means satellite will appear stationary with respect to Earth. So it will always look towards our Bangalore center. So you have constant communication at one place. Generally that is the idea with which satellite communication happens. But here I just want to give you example of this is now the other way of doing it. Starlink, OneWeb, all of you would have heard about this satellite. Some 4,000 Starlink satellites are there. OneWeb is going to launch around 750 satellites. The difference is they are all low Earth orbiting satellites, like our remote sensing satellites. So they will always move around the Earth from North Pole to South Pole. So it will look at one part on Bhavnagar today. After 10 minutes, it will be looking somewhere else. So that is the difference between a geostationary and low Earth orbiting. Why they are important? You know about Russia-Ukraine war. Ukraine is almost totally devastated. It is bombed like anything by Russia. Everything is destroyed there. TV towers, all infrastructure, communication network, everything. But you will be surprised to know that today also TV is working there and internet is also working. So how it is possible when so much bombing has happened? That is due to this Starlink satellite. So Elon Musk, it is owned by Elon Musk. He is providing these services through satellites. So that is the importance of the satellites, especially in such scenarios. So it is high time India also should, of course this OneWeb is now owned by Sunil Mittal of Airtel. He has taken over. This is the UK, government of UK is also part of this venture, but this is going to be the trend now as far as communication is concerned, and India should also participate in that. Navigation, all of you know GPS. What you don't know is that 95% of activity which you do is in some way or the other governed by GPS as on today. You will not know, but you are becoming slave to that GPS technology. So after Kargil war, what happened that our soldiers had lot of difficulty. So either USA was deliberately degrading the resolution or the signals were denied to our soldiers. So what happened was that our weapons didn't work properly. So a lot of soldiers died in Kargil war. So after that government decided that we should have our own GPS or navigation system, because it controls everything, especially in military. So with that idea this was set up, and now we have 7 satellites. Of course 3 are not working, so we are working on that replacement, and many problems are there technological. So these are all the activities which we do, which are governed by GPS or GNSS it is called. So almost 95%, 53% location based service, almost 38% road transportation. Whether you go by air, train, road, vehicle, your own car, everything, Ola, Uber, everything is governed by GPS. So that's why, as I said, all these activity which you do in your life, almost you count it, it will be 95% work which you do. Somewhere or the other it is influenced by GPS. So we want our own system. So this is how we have tried to see that it is not working. So we are providing services to Indian Railways. All Shatabdi, Rajdhani Express are controlled, or their movement is tracked by Okay, it will not work because it's a PDF. PPT it is also. So all our railway engines are tracked by combination of navigation and communication. So wherever trains are moving, we are tracking it continuously in real time. Similarly, all boats, fishermen, when they go out in deep sea, everything is controlled and monitored at one place by Indian Navy. Because after Bombay happened, so we wanted something so that any unknown boat doesn't enter into our territory. So now all Indian boats are fitted with this terminal, so they are regularly governed by that. Somebody wrote to Prime Minister that lot many soldiers die in Siachen. All of you know, Siachen glacier, we sent our soldiers for every 3 months or 6 months, new batch go. Many times avalanche happens, snowstorms, whole battalion get lost, they get buried inside the snow, and we are not able to even locate their bodies. So somebody wrote to Narendra Modi Sahab that we have so many technologies and all we claim, we are not able to track our soldiers. So now we are trying to make a wearable like this watch-like terminal which we have put in trains or aircrafts and boats. So soldiers cannot carry a big one because they have lot many other things to carry. So a wearable type of device, but it has to survive in -55, -60 degrees centigrade. It has to work there for 3 to 6 months when they are there. No battery charging, anything is possible, so it has to last, that battery has to last for 3 to 6 months. So all these are challenges which we are trying to take care, and then regularly their movements will be traced from Srinagar or New Delhi. So that is the idea which we are working on. And of course, ultimate is like GPS in your mobile, Navic in your mobile. So Navic is our Indian GPS, navigation with Indian constellation. So after a couple of years, you will hear a lot about that. Many advanced technologies we are doing. The problem with our navigation satellite is due to this imported atomic clock, because all the navigation satellites have a clock which is called atomic clock, like your watch, which is very accurate. 1 second delay also you don't tolerate. Here it is 1 second in 10⁻13 seconds. Means almost millions of years it will deviate by 1 second. So that is the stability of that clock. Then only you can achieve 5 meter or 10 meter accuracy of GPS. So this is how it is related. So we are working on our own clock, because right now we are using imported one from USA or Switzerland. Then we are having our own transmitters, earth stations, then terahertz astronomical observations, telescope, all these things right now we are importing. So indigenization is one other, detectors for all camera systems. They are also very costly thing. Many times they will take years to deliver. So all these things are their way of denying you technology also. They will take the order and then they will not deliver. Or they will take 3 years, 5 years, 10 years to deliver. So all these things are the problem we face everywhere. All of you also may be facing. Chandrayaan 2, all of you know, so I don't have to tell. We failed in that. Failure I was talking. We could not land. Of course, orbiter is working very well. So that's why these images which we got. So if you want to study moon also, sitting here you can study it with these images. We are making this Chandrayaan 3, and shortly I hope that you hear good news of India landing on moon by June, July, August this year. We are ready with that. So this is that Chandrayaan 3 lander. Of course, now we will not have orbiter, we will have only lander, and hopefully this failure is a thing of the past. This year we will hear good news about that. And lastly, Gaganyaan, which, as I said, Sarabhai said, don't do all these things, but we have to do it to acquire technology. We want to put our Indian man from Indian soil in an Indian rocket into the space. It will move around for 2 to 7 days and then come back on Indian soil. So that is the difference, because earlier Rakesh Sharma is gone, Sunita Williams, Kalpana Chawla, all of them, they were Indians. They were born into space. But what is new is that everything is Indian or indigenous. Our rocket, our cabin, satellite, and this over satellite will put a room like this where astronauts will be sitting, 1 to 3 astronauts. And the approach is, ISRO knows how to do engineering, technology, science, everything. But what we don't know is human-centric. Is anything when human being is involved in space, Means it's like when you fly in an aircraft, everything has to be perfect, otherwise the aircraft will not survive. So same way here also we have to be perfect. So safety takes the prime role. So that we are also learning. We know engineering technology, so failure happens because technology can go wrong. But here we cannot afford a failure. Space shoot is another thing which. So this is like this will be the cabin where 3 people can sit. So initially we may send only 1, finally 3, 2 to 7 days, around 400 kilometer orbit. They will move around, land somewhere near your place in Veeraval or somewhere. It is not yet planned, but we are examining different sites: Veeraval, Goa, Bay of Bengal, Andaman Nicobar. Any of these places they will come back. And as I said, human rating is important. Even changing a small code or putting a small screw into the orbit or the spacecraft, it will undergo a lot of certification and testing. Without that, nothing can change. One more thing, like a mother doesn't leave her child away, isn't? Like that, we are not going to leave astronaut away for even a second. Means always they will be in touch with us when we launch them. So for that, right now with all available technology, we are able to achieve only 40% communication. So 100% communication is the must when I want to put a man in space. So from 40 to 100, the distance we have to cover. Last 3 years we are doing that only. So we try to rope in other space agency. We have to launch 2 more communication satellites because Gaganyaan is always moving from North Pole to South Pole. So it will remain in Indian visibility only 2 times in the morning, 2 times in the evening. So rest of the time it is moving somewhere else. So from there it will communicate. This is Gaganyaan. It will communicate with our geostationary satellite, which will always look towards Bangalore or some common place in India. So always they will be in touch in this indirect way when they are not over India. When it is India, they will directly be in touch with us. And when you communicate with them, except for their family members, we will not allow anybody else to communicate with them. Only one person who will be trained to handle them, because psychologically their state we don't know. So these are all elements I was telling, human elements, biological elements, which will also we have to learn, because if 10 type of people talk with them throughout the day, their mind may get disturbed. So there will be one person who will be trained to talk with them, except for family members. And our family members will be allowed to talk during this period. They will be the only people who will be different from that one person. So all these many new things, our people are taking training in USA, in France, many other places to learn about putting man in space. So these are the challenges which we are going to face. And so 100% communication means we will be in touch with them through audio, video, email, internet, everything. So this will provide us, this network will give us that flexibility. Of course, I told you about NISR. So we made an airborne radar which flew across whole USA to get data, so that scientists learn how to use this NISR data when actual satellite is launched. Before that, the airborne radar systems campaign we did. So this data is available. Researchers can use the data to understand how this will look like, how it will be put to various applications. And then we have a joint mission with France, which is getting planned. It has a lot of ocean applications. That's why I'm showing it here. So this is going to be a very important international project, which we'll be doing it with French Space Agency. And then we are working, all of you know Quad. There is under Quad, we have a space working group. India, Australia, Japan and USA. They have formed a Quad group. Like G20, we have a Quad also. So all of us are working in space, all these 4 countries. So we are trying to help these small island nations, because this directly relates to your applications. Because many of these islands, they are now moved by China. Because China is, you know what happened in Sri Lanka, like that Maldives, Mauritius. These are the places where China is trying to penetrate. So as a group, we are trying to help them, this island nation, so that influence of China gets reduced in these places. So there are strategic reasons, there are other technical reasons, scientific, but there are a lot of scientific applications in this working group where we are working on that. Of course, ISRO is part of many of these international missions, international agencies, international meetings, all those things. This I already told, so I don't. So there is a airborne radar which can penetrate below the surface. So that is another area where it is going to be a newer technology. And lastly, quantum frontiers and at AI we already talked. So AI has application in almost all the field. And deep ocean exploration, you people know better. So as I said, we are feeding into the with our ocean sat and many other activities related to ocean. But this is one thing which you are going to hear a lot in future also. If some of you are aware of that, quantum physics or quantum frontiers. So right now cyber frauds happen, lot of cyber thieves are there, your money gets stolen, your transaction get affected, your password gets stolen, you are hacked. So all these things can be taken care only by encryption. Encryption anybody can break. As on today, whatever encryption you do. So now what will happen is that your password or the keyword or the OTP which comes to your mobile, right now it is coming through air or through fiber optic network. Instead of that, it will come through photons. So through this quantum frontier. So this is going to be the technology where other data which is encrypted will come through normal channels, whether it is RF, fiber optics, anything. But your OTP will come through these photons. So we did this experiment from one building to another, and future it will be through satellite. So this is my campus here in Ahmedabad. So one building, 38 building to 52, 20 building, we did this experiment, 300 meter in space. We transmitted data, text message, image, video conferencing also we did. So while data moved through normal channel, the password for that encrypted data came through the photon channel or what is called quantum channel. So this is going to be, here you don't need high data rates, it will be on some few hundred kilobits per second. And we are going to put up a quantum payload in our next satellite which we are going to launch on 22 April. So lot of new things are happening in this quantum frontier. So that is one area where many researchers who are interested can work on that. Another area is astronomy and astrophysics in a sub-millimeter wave or terahertz technology. So terahertz technology is another new area where a lot of research is happening in the world. One is quantum frontiers, other is terahertz. And we are setting up a telescope which will be India's first indigenous telescope in 300 gigahertz and future in 1000 gigahertz, that is 1 terahertz. In Henley. Henley is considered to be one of the most quietest place in the world, especially in India, because the ambient noise is very low. So from there you can pick up signals from space without getting affected by the ambient noise. So this is another area of research which many of you, these are some of the facilities available at my place in Ahmedabad. So please, whenever you visit Ahmedabad, try to see, we have a 3D immersive display where you can visualize all these images which I have shown in a better way. Lot many facilities in our new campus, and it can house 6 satellites at one time. Even China doesn't have such a big clean room as it is called. Of course, from whatever information available with us, but you don't know Chinese. So this is how a very big thermowave chamber. So now private sector can utilize these facilities. So summary, remote sensing, navigation, communication, science and technology applications, any area you can think of, we can work together. SAC is the right place, happening place. For that we have a very good exhibition. We do run many courses also where you can participate if some of your colleagues or anybody is interested. So we do a lot of things, but still many things can happen. Just in view of the occasion of this thing, India still has far way to go. CNR Rao, I was mentioning about him, he said that we are unnecessarily obsessed with agencies like space and atomic energy. Today I told you about space, but real research happens in small laboratories, research institute like yours. So please do take up research activity. Actually they do happen in small places only. And then, as he said, that we are unnecessarily obsessed with people like us. We do invest very small amount compared to USA or China or anybody, but hopefully we'll catch it up. But still, instead of quantity, we should emphasize more on quality. That is the basic idea with which I have put up this. One of the scientists, Bhargava, only said that we have very good scientists, exceptional one, but most of them are mediocre also. So how that we overcome this mediocrity? Because we get many PhDs, but whether they are really doing that cutting edge work, so that's why I try to put up some areas. As I said, I am more a patient rather than a doctor. I can only show you the topics where a lot of research is happening in the world. So these are the areas where some of the researchers, JRFs or anybody who are there in your center also can take up activities related to that. Thank you for giving me this opportunity. If you are not bored enough, any question is there, I can take it up. If not now, afterwards.
धन्यवाद देसाई सर, आपके द्वारा सैक इसरो के योगदानों, गतिविधियों और आगे आने वाले अवसरों के बारे में जानकारी देने के लिए आपको धन्यवाद। अब मैं हमारे निदेशक महोदय से अनुरोध करूंगी कि वे हमारे विशिष्ट अतिथि डॉक्टर बी गोपालन और हमारे मुख्य अतिथि श्री नीलेश एम देसाई को स्मृति चिन्ह प्रदान करें। श्री डॉक्टर गोपालन सर को भी। अब मैं हमारे निदेशक महोदय को CSMCRI स्थापना दिवस संबोधन के लिए मंच पर आमंत्रित करती हूँ। सर, आपका स्वागत है। निदेशक महोदय के संबोधन से पहले हम आज की अवार्ड सेरेमनी शुरू करेंगे। प्रत्येक वर्ष संस्थान के विभिन्न प्रभागों और अनुभागों के सर्वश्रेष्ठ कर्मचारियों को पुरस्कृत किया जाता है। इस वर्ष अनेक विभागों से सर्वश्रेष्ठ 6 कर्मचारियों का चयन किया गया है, जिन्हें आज के कार्यक्रम में प्रमाण पत्र प्रदान किए जाएंगे और साथ ही साथ प्रत्येक विजेता को 2500 रुपए का नगद पुरस्कार उनके बैंक खाते में पहुंचाया जाएगा। मैं अवार्डीज के नाम लूंगी और मैं देसाई सर से अनुरोध करती हूं कि वे सर्वश्रेष्ठ कर्मचारियों को प्रमाण पत्र प्रदान करें। तो पहले कर्मचारी हैं श्री जयेश कुमार चौधरी, सीनियर टेक्निकल ऑफिसर 1। A.H. लखानी, सीनियर टेक्नीशियन 2, श्रीमती सरला M. सोलंकी, टेक्नीशियन 2, श्री चेतन प्रकाश, ASO, श्री मनीष R. वसावा, टेक्नीशियन 2, श्री इलियास B. बेलिन, टेक्नीशियन 1, संस्थान में आप सभी का योगदान व सेवाएं सराहनीय हैं। आप सभी को हार्दिक बधाई। कर्मचारियों के अलावा संस्थान निर्माण व विकास में शोध छात्रों की भी अहम भूमिका होती है। उनके प्रोत्साहन के लिए पिछले 2 वर्षों से सर्वश्रेष्ठ छात्र एवं छात्रा पुरस्कार को भी फाउंडेशन डे प्रोग्राम में सम्मिलित किया गया है। इस वर्ष मिस्टर स्नेहाशीष देवनाथ एनालिटिकल एंड एनवायरमेंटल साइंस डिवीजन से सर्वश्रेष्ठ छात्र के लिए चयनित किए गए हैं। मैं गोपालन सर से अनुरोध करूंगी कि वे हमारे पुरस्कृत विद्यार्थी को पुरस्कार प्रदान करें। सर्वश्रेष्ठ छात्रा के लिए मिस प्रेरणा शर्मा मेम्ब्रेन साइंस एंड सेपरेशन टेक्नोलॉजी डिवीजन से उनको चयनित किया गया है। मिस प्रेरणा शर्मा, उनके अगर वो नहीं है तो उनके विभाग से कोई और भी उनके बिहाफ पे आकर पुरस्कार ले सकता है। पुरस्कार की अगली श्रेणी में राजभाषा कार्यान्वयन में उत्तम कर्मचारी पुरस्कार है। संस्थान में आधिकारिक कार्यों में हिंदी के प्रयोग को प्रोत्साहन देने हेतु हिंदी में सर्वश्रेष्ठ कार्य करने वाले स्थायी कर्मचारियों के लिए यह पुरस्कार रखा गया है। इस वर्ष सभी के लिए श्रेणी में श्री राजदीप वरिष्ठ सचिवालय सहायक को यह पुरस्कार दिया जा रहा है। मैं निदेशक महोदय से अनुरोध करती हूँ कि वे हमारे अवार्डीज को पुरस्कार दें। दूसरी श्रेणी जो गैर हिंदी भाषी श्रेणी है उसमें श्री इलियास बी बेलिन टेक्नीशियन 1 को यह पुरस्कार दिया जा रहा है। धन्यवाद सर। संस्थान में स्टाफ क्लब द्वारा स्टाफ एवं छात्रों के लिए खेलकूद, कला, लिटरेचर, मनोरंजन से संबंधित अनेक गतिविधियों एवं प्रतियोगिताओं का आयोजन किया जाता है। फाउंडेशन डे के उपलक्ष्य में क्रिकेट एवं वॉलीबॉल टूर्नामेंट का आयोजन किया गया, जिसमें स्टाफ और छात्रों ने बढ़ चढ़ के हिस्सा लिया। आज के कार्यक्रम में विजेता टीमों, रनर अप और विनर्स को और साथ ही साथ सर्वश्रेष्ठ खिलाड़ियों को पुरस्कार दिया जाएगा। मैं गांगुली सर से अनुरोध करती हूँ कि वे हमारे विजेताओं को पुरस्कृत करें। पहला कैटेगरी है मैन क्रिकेट टूर्नामेंट, जिसमें टोटल 8 टीमों ने पार्टिसिपेट किया था। इसमें मैन ऑफ द मैच टीम सीनियर 11 से धनाजी गायकवाड़ को जाता है। मैन ऑफ द सीरीज भी धनाजी गायकवाड़ को जाता है। उसके बाद मैन क्रिकेट में जो रनर अप टीम रही है वो CSIR-CSMCRI परमानेंट 1 टीम थी, जिसके कैप्टन नीरव गादिया जी को मैं यहाँ आमंत्रित करती हूँ। वो और उनकी टीम को हार्दिक बधाई। और मैन क्रिकेट टूर्नामेंट की विनर टीम सीनियर 11 के कैप्टन धनाजी गायकवाड़ को मैं इनवाइट करती हूँ। धन्यवाद सर। अब हम मैन वॉलीबॉल टूर्नामेंट के पुरस्कार देंगे, जिसमें टोटल 12 टीमों ने पार्टिसिपेट किया था। मैन ऑफ द मैच में टीम सुपर 7 से राजवर्धन को चुना गया है। मैं हमारे प्रशासक नियंत्रक सुभाष चंद्र जी से निवेदन करती हूँ कि वे हमारे विजेताओं को पुरस्कृत करें। मैन वॉलीबॉल में मैन ऑफ द सीरीज टीम सुपर 7 से संजय यादव हो रहे हैं। रनर अप टीम G7 से कैप्टन प्रणय कुमार को मैं आमंत्रित करती हूँ। मैन वॉलीबॉल टूर्नामेंट की विनर टीम सुपर 7 से मैं कैप्टन संजय यादव को आमंत्रित करती हूँ और उनकी टीम को हार्दिक बधाई। तीसरी श्रेणी है वुमेन वॉलीबॉल टूर्नामेंट, जिसमें टोटल 3 टीमों ने भाग लिया था। इसमें प्लेयर ऑफ द मैच पैंथर टीम से जसवीर कौर माहे हैं। प्लेयर ऑफ द सीरीज वुमनिया टीम से शिल्पा दावस हैं। टूर्नामेंट की रनर अप टीम वुमनिया की कैप्टन पद्मजा वाकचूरे को बुलाती हूँ और उनकी सभी टीम मेंबर्स को हार्दिक बधाई। और वुमेन वॉलीबॉल टूर्नामेंट की विनर टीम पैंथर की कैप्टन प्रियंका पात्रा को आमंत्रित करती हूँ और उनकी टीम को हार्दिक बधाई। तो हमारी अवार्ड सेरेमनी हो गई है। अब मैं पुनः हमारे निदेशक महोदय से अनुरोध करती हूँ कि वे CSMCRI स्थापना दिवस संबोधन के लिए मंच पर आएं। सर, आपका स्वागत है।
Yeah, fine. Good afternoon, respected chief guest of today's function, Shri Nilesh Desai, respected guest of honor of today's function, Dr. B. Gopalan, my colleagues from the CSIR family, attending from both virtually, because this whole program is live YouTube telecasted, and almost the invitation is sent to the entire CSIR fraternity. Roughly around 15,000 people we have circulated the celebrations of our Foundation Day, which is YouTube telecasted live, and all my CSMCRI colleagues and the students, the research scholars, all the invitees of today's celebration, and whomsoever who has basically been present in this function, to be part of it, to feel about this institute, my pensioners who have been attending this mostly through YouTube, and all well-wishers of CSIR-CSMCRI family, press and media, शुभकामना है 70th CSIR-CSMCRI फाउंडेशन डे के लिए। This Foundation Day is probably one of the very, very unique Foundation Day in the history of this institute, because it is camouflaging with another unique program initiated at the headquarters level called as 1 week 1 lab, which is going to be done across the CSIR labs for the next few months till September 26, 2023, which will happen in Delhi, where we'll be having a kind of a big event where almost all the 37 laboratories would have celebrated the achievements, the contributions, the recognitions, the capabilities of the labs at their own labs as well as in the labs of others. So this is a kind of a unique, celebrations that we are having it. Of course, the idea was mooted by our Honorable Science and Technology Minister, Dr. Jitendra Singh, in the CSIR Foundation Day celebrations. When we had a kind of a leadership meet in Delhi, he mooted this idea, which was then inaugurated by Central Building Research Institute as a kind of an opening batsman on 6th January 2023. When these programs are necessarily done for two major reasons. Foundation Day are celebrated for primarily, especially this particular Foundation Day is celebrated for two reasons, major reasons. One is to tell the outside world what the institute has been doing and how the institute is basically benefiting the society, how the institute is helping the industry, and that's what is all about. That's basically the recipient end, to make the awareness and visibility of the institute in the eyes of others is one of the fundamental reasons for such celebrations. What is the second thing? The second thing is reflect internally and see in what way our work is positioning ourselves to a kind of a meaningful outcome, which Dr. Gopalan was addressing in his Foundation Day lecture. How do you basically make it a kind of a usable outcome that is getting translated in the benefit of the industry or the society? So these Foundation Day gives you that kind of a lot of internal reflections and corrections, positioning, course corrections, all those things will get reflected on this. Of course, this Foundation Day also gives you a lot of happiness moments. It's very clearly reflected by the backbenchers with the kind of enthusiasm they demonstrated it. Good things have to be learned, good things have to be shared. It's very important. Okay, all big organizations, they celebrate achievements, and it is good. Celebration of achievements has to be encouraged, and such kind of a moments also gives you an opportunity to have a kind of a reflections as well. And this particular year is no difference. If one were to look at it in the institutional performance matrix, okay, as I said, I mean, institutions are largely governed by what kind of a technologies. And CSIR, as I said in the morning in the inauguration of the OWOL program, we are a kind of a research institutions are beautifully positioned compared to academic institutions or industry, where there's a kind of a beautiful interface exists. Okay, if I see the slides of Mr. Desai, every slide is finally leading into a kind of an application which is going to have a kind of an implication on the lives of the common man or on the growth of the nation. It's very clear. Okay, I mean, every slide, whatever the slide that is put, I mean, and they're all backed by technology, which might be backed by fundamental science, which he has not touched upon. Certainly it must be backed by a fundamental science. Maybe the fundamental science which has been discovered earlier. I mean, I'm sure that some of you have recently read the two physics guys who did the quantum, confinement theory way back in 1930s. There was a kind of an evaluation which was done, how that invention which was done without having any kind of an implication. And whatever we are talking about, AI, human intelligence interface, all those kind of things. And the current one that he is talking about on quantum based cryptography. Okay, all these things are fundamentally boiled down into those kind of a fundamental physics which was done, which was discovered sometime in 1930s. And there was an evaluation which was done, and I'm told that evaluation is the outcome of that evaluation of the science, which has been published in a couple of papers by those astounding physicists, is few $1 trillion. That's the kind of an implication people make. That's the kind of an implication science makes. Not in $1 billion, it's in $1 trillion. And that's the kind of a science. So truly, I mean, there is a kind of a very strong backward integration. Yes, research institutes like us should be basically positioning ourselves as I mean, we said we are a kind of a CSIR is scientific and technological organization. So technology is the fulcrum. Whatever we do, it has to basically lead into a kind of a technology backed by a kind of a fundamental science. Either we absorb the fundamental science which is generated from CSIR or adopt the fundamental science which is generated from the rest of the world. So if one were to see on the institutional performances, there are a few metrics which I just wanted to share on this forum, which will also gives you a kind of a reflections. This particular year, we have transferred something like around 11 technologies to different industries and societies, MSMEs and startups. I think this is probably a very good development. The reason being, the earnings from the technology license is one of the highest in the recent years. Really one of the highest in the recent years. That clearly shows how we are remaining relevant in terms of technology. And it is important, of these technologies, there are certain technologies that we have licensed or creating a kind of a unique position for this country. Like for example, we are all talking about hydrogen as a kind of an alternate fuel for this country. Okay, we have not even touched, we are nowhere closer to even the tip of the iceberg as far as hydrogen is concerned. Okay, and this particular technology requires a special kinds of membranes that is unfortunately has been monopolized by few countries in the world. And there is a high likelihood there's a kind of a technology denial to happen on this domain in the years to come or in the decades to come, which we are not going to foresee now. The way that the space scientists are foreseen about the technology denial in 1970s and 80s that culminated to the indigenization. Indigenization is not because they wanted to do it, because they were forced to do it. Okay, they were forced to do it because when you are having a kind of a denial, tomorrow, if we are going to do everything, let's say for example, 10% of the Indian vehicles to go on hydrogen, where are we going to get these membranes from? Okay, this is a kind of questions that scientists like us should be basically questioning, and that gives you a kind of a purpose, and that purpose drives to a project, and that project leads into a kind of an outcome. The outcome may basically lead into a kind of a translatable outcome, leading into a kind of an application or a product or a process. There are many in that whole funneling chain we may fail. Okay, I was so happy when Mr. Desai was pointing it out. He didn't have any fear of telling that we failed in this. There are very few people in the scientific fraternity who blatantly say we failed in this, because we always enjoy celebration of success. Okay, and failing is sometimes, in a kind of an R&D environment, you need not necessarily have to succeed all the time. We try, sometimes it works, sometimes it doesn't work. And Dr. Gopalan's lecture, those who have attended 3 days back when he gave, he said, one of the technology which they transferred for $200 million. It's not a small money. $200 million is not a small money for one molecule. Okay, but it did not take off. Had it been taken off, it would have created a kind of $1 billion market, but it did not take off for whatever the reasons known to the the guys who have licensed the technology. So it has different layers. It has different layers. One has to understand that. Okay, so I think our idea of technology is about that. Another important thing is, I'm just giving you a kind of a wide examples to give a kind of a feeler how India has to position through these kind of technologies. All of you are aware about the the potassic import, and many of you are not aware. In fact, in one of the forums I might have told is because of the war. For your kind information, everyone knows. Okay, whatever the potassium which is used by my Indian farmers, and not even a gram is manufactured in this country. And NPK is a kind of a standalone formulation of fertilizers needs to be used by the farming community of this country, period. No second opinion on that. Absolutely no second opinion on that. Where do we get? Tomorrow if three countries decides we are not going to give potassium to this country, our productivity goes down so significantly that we have to import our staple food commodity, and that's the kind of a situation. Okay, and food is inevitable commodity that one has to have. And alternatives, when we are toying it around, we toyed it around for one of the molasses-based distillery spent wash, but that was not the end of it. We went one step further and then said, why not we basically extract the same kind of a potassium from ash, which is generated from the Indian distilleries who have set up the kind of this thing. And that was another kind of why these things are basically, why we have to work on those things, because we wanted to create a kind of a self-reliance. Tomorrow if my distilleries are put into use of making potassium extracted either from the spent wash or from the ash, it is going to at least help something like around 10% of, if not full, 10 to 12% of potassium dependence on the rest of the world. At least we make a kind of a good beginning. At this point of time, we are none. So there is a kind of a transition that we are basically positioning ourselves. Technologies, and these technologies, when it is getting adopted, I was so happy when I was talking to the guy who is basically licensed a technology for which the commercial plant is going to come up in Uttar Pradesh. I was so happy, sir, July में plant लग जाएगा, commission हो जाएगा plant, और वहाँ पे पोटाश शुरू होगा, वहाँ पे अभी एनिमल फीड भी बन जाएगा और इंडियन फार्मर्स को जाएगा पोटाश. I think that is the most happy moment for ours. These kind of a technology. Tomorrow, if the guys who are basically manufacturing these membranes are going to be complementing on the hydrogen electrolyzer in the fuel cell application for making hydrogen, and that's the happy moment. It's not licensing. Please understand that licensing is one step towards the success. One step towards the success. When it actually gets translated into a kind of a commercial viable industry which is sustainable on its own, then it makes a kind of a great impact. And for which what is necessary? The necessary is to create a kind of an intellectual value. What is necessary is to create an intellectual value. Are we better positioned in the intellectual value? Yes, we do file patents. CSMCRI is one of the top 3 institutes in the entire CSIR in terms of filing of patents and in terms of granting of patents. Okay, we contribute roughly around 8 to 12% of the share of entire CSIR family. But are these sufficient? 90 scientists we are working, and we've been filing something like around 15 patents, original patents, 15 patents, and granting roughly around 20 to 25 patents. Is this sufficient? We'll have to self-introspect. We must have more number of disclosures. This has been told very significantly in our Research Advisory Council meeting, that we must have more disclosures, we must have more IP filings. And this has to come from all the scientists. So I take on this occasion that please ensure that we file more number of IPs, especially the people who are working on an application-oriented research. Don't go for the publication first. Protect your, because any technologies that we are going to license it, the first question that is going to be asked by the licensee is your work is intellectually protected? The first question that he or she is going to ask is only that. And if you are not protected, your technology is not going to be valued at all. And this is not, these technologies are going to basically serve to the industries. This is not in a strategic space, unlike in space. So this is something which we have to basically improve upon. And as far as the high impacting research publication is concerned, this institute has been doing phenomenally good. I must congratulate all the scientists working in this institute who have done remarkable contributions in creating a kind of a fundamental knowledge. Amazing, amazing. Because I just, when I was making a kind of a, a data assessment of this particular research publication front, we are way ahead of national average, way ahead of national average. Our average, the impact factor is one of the metric, easy to do. Mathematics is easy to, if you have a kind of a data and then do a kind of an analysis, it's easy to make a kind of a, comparative assessment. Our average impact factor is something like around 5.8, which is far, far higher than that of a national average, far, far higher than that of many of the national institutions in this country. And that too, with a kind of a quality of, not only in the quality of publications, but in terms of the quantity also, we've been very, significantly high in the last, at least, maybe I would say that the highest ever in the history of CSMCRI. Okay, roughly around 280 publications plus. That's a really, really, heartwarming situation. But these quality science needs to be, preceded by a kind of an intellectual value, succeeded in terms of translation. And that's what we should be basically aiming. All the other parameters, whether it is a kind of a number of PhDs we produced, or number of interns we have trained, or number of project staff that we have been grooming, all these things are all kind of a spin-off of these outcomes. And this particular, I must, the entire credit goes to the scientific community and the research scholars and the project assistant community of this institute who have been successful in getting this kind of what do you call amazing outcome. I mean the institute has been working on kind of a visionary projects, and most of the projects, I'm telling you, most of the projects we have been doing it for the last maybe 5 years without seeing a kind of a ray of hope. I mean, we do have a kind of some sort of a passionate attachment with some of these projects, because these projects have a huge implication. I was discussing today morning with Dr. Gopalan whether it is on the double fortified salt or it is a single stage seawater desalination membrane, or it is a kind of a assessment of the entire Indian coast for the seaweed opportunity potential that is going to help thousands of coastal people to have a kind of a livelihood option. And these projects are not so, what do you call, projects that is going to have a kind of a project report or a patent or a publication. No. These projects are going to have a kind of a significant implication in terms of our growth. Our growth means not institute growth, nation's growth. And that is the way that we are basically positioning ourselves. Tomorrow if you see, I mean, like for example, I mean, if I know these are the, let's say for example at the end of the seaweed projects that I'm telling that, I mean, these are the 120 locations in this India country map with a kind of a geo coordinates I'm giving you, and this is the area, and this is the kind of a method that I'm going to give, and this is the kind of a seaweed that you can cultivate it. Just go and then start doing the cultivation, and you are going to have an assured income of so much money. Just imagine you are going to create a kind of an employment opportunity to thousands of people. The science is basically leading to a kind of an application which is affecting the income of our people. And that's not a simple thing. That's not a simple thing. Almost many of the projects, a very simple example is the mobile desalination plant that we have got. Okay, I was so happy when I saw the first time government of Kerala when they showed for a what do you call order for 3 desalination plants. I was so happy because it's not that institute is getting a kind of a revenue generation. Nothing. Institute revenue generation. In fact, I mean, if I were to ask about the institute revenue generation, we are nowhere near the kind of a target that we have set. We are nowhere near the target. Okay. Fortunately, we have improved compared to the preceding year. This year we have improved. Okay, our external cash flow has increased over 10 crores. Okay, but I mean, if I were to basically put a kind of a target, which I've set, I mean, 3 years back in my inaugural, after I became a director in the inaugural Foundation Day address, I said at least we should be basically, securing 30% in next 2 years time frame, which is today. But we have not. We have not crossed the jinx number of around 17 to 18%. And our budget, all of you know, our budget is roughly around 55 to 60 crores, and which means that we have to earn something like around, close to something like around 15 to 20 crores. We are nowhere closer to that. And that's an area that we should be basically focusing very strongly. Why we are not in a position to write a kind of a very high value projects? Why we are not developing certain technologies which generate a kind of a high revenue opportunity? Why we are not contributing on a kind of a technical intervention that is going to create a kind of a larger implication? And that's an area that we have to basically talk about. So as I said, I mean, it's not about this is as far as the revenue generation is concerned, but the revenue generation for the institute is only few tens of crores. But what is important is how it is influencing the society. Like for example, one of the technologies, I mean, the seaweed technology that we have, licensed to one of the companies in Gujarat. On the other day, when the product was launched under the trade name Sivarica, okay, I was so happy because that particular product is going to reach to the farming community of this country. Just imagine millions of farmers are going to use this product and use it for their agricultural crops and make a kind of a productivity increase, which is going to basically indirectly benefit my farming community, and that's the biggest intervention. The license fee may be a couple of tens of lakhs. but what is its implication in terms of my farmers' additional income? That's really impactful. One of the estimates we have done for the previous product is running into few thousands of crores. The license fee is only 1 crore, but it is having an implication of 3 to 4 orders of magnitude, and that's what science and technology can create. So I sincerely, of course, I mean, as an institute, we've also been, performing on many things, like for example, whether it is on skill development through several programs, or in the scientific outreach through Jigyasa. We've been doing on many quarters, or in organizing international conferences, or getting awards, both by our scientists and by the students, getting a kind of a prestigious fellowships, and all quarters we have been doing it. Okay, but all these are all, to me, is a kind of a output of what we have been doing, which is going to have a kind of a larger ramification and implication. So I sincerely request on this occasion that we must rededicate ourselves to see how we basically, what the work that we are doing it. I mean, every one of us, I mean, when we see the vision and the mission statements, every one of us should basically see that how am I basically inching towards in making my research to be made into a kind of a meaningful outcome. If each one of us collectively take that onus on us, and these things cannot be preached by directors, please understand that. Director is a one-man person. He is only an enabler. That's what I told Dr. Gopalan. मेरा job तो enable करने का है, मेरा job तो connect करने का है. ये मेरा job है. I know what is the definition, and I wanted to give direction to the lab in terms of what we need to do, what we should not do. That's all is the direction of that's all is the responsibility of a director of a lab. Okay, but what is to be done is the scientific community and the research community, and it is important that we are adding lots and lots of manpower. Okay, I must thank on this occasion my controller of administration, who has been very, very aggressively doing in terms of adding workforce for this institute. And lots of technical manpower is added, and many administrative support function manpower is added. And we will be adding some more in this year. Wanted to make a kind of a close to our sanction strength status quo. Because at the end of the day, work has to be done by the people. If you don't, there are 3 things are necessary: people, funds, infrastructure. If these 3 things are there, people can do any kind of a wonders. Okay, and we are going to add more number of people. Now hopefully, I mean when we are meeting next year, and these people are going to be added, and it is going to accelerate in our outcome. What is important is the efforts that we are trying to do is supposed to do a kind of an acceleration in our outcome. And if we are getting that kind of an outcome getting accelerated, I think we should be positioning ourselves better in the eyes of the world. Not to India, not to CSIR, but in the eyes of the world. So with this, I sincerely, congratulate you, all the people, all the staff members and their family on this auspicious occasion of 70th CSIR-CSMCRI Foundation Day celebrations, which is a kind of one more landmark in the history of this institute. And we, especially the people who have joined recently, they are the people who will be creating a kind of a large difference in the decades to come. Thank you.
धन्यवाद निदेशक महोदय। अब हम कार्यक्रम के अंत की ओर बढ़ रहे हैं, और इस क्रम में मैं हमारे प्रशासन नियंत्रक श्री सुभाष चंद्र अंतिल जी को धन्यवाद ज्ञापन के लिए आमंत्रित करती हूं।
धन्यवाद। आप सबको सेंट्रल सॉलिड के 70वें स्थापना दिवस पर की शुभकामनाएं। हम अपने कार्यक्रम के अंतिम सोपान पर पहुंच गए हैं, और साइंस एंड टेक्नोलॉजी की बहुत गहन यात्रा के बाद और अब हम अपने अंतिम पड़ाव की तरफ सब लोगों को लग रहा होगा कि इतना एनरिच होने के बाद थोड़ा चाय और बिस्किट का हो जाए। तो उससे पहले मैं धन्यवाद देना चाहूँगा यहाँ उपस्थित सभी गण्यमान्य व्यक्ति जिन्होंने इस सभागार को अपनी उपस्थिति से सुशोभित किया। सर्वप्रथम डॉक्टर बाला सुब्रमण्यम गोपालन, जिन्होंने इतने अपने बिजी शेड्यूल और इतनी अधिक अपनी आयु के होते हुए इस कार्यक्रम में अपनी शिरकत की। और साथ ही मैं धन्यवाद देना चाहूँगा हमारे मुख्य अतिथि श्री नीलेश एम देसाई जी को, जिन्होंने टेक्नोलॉजी की एकेडमिया में हमें अंतरिक्ष की सैर कराई और अपना अंतिम इतना कीमती समय निकाला। और मैं धन्यवाद देना चाहूँगा अपने निदेशक महोदय डॉक्टर कन्नन श्रीनिवासन जी को, जिनके गाइडेंस और अप्रूवल से ये कार्यक्रम संपन्न किया जा सका। और धन्यवाद देना चाहूँगा मैं इस कार्यक्रम के कोऑर्डिनेटर डॉक्टर विश्वजीत गांगुली जी को, जिन्होंने इस कार्यक्रम को सफल बनाने में अपना भरसक प्रयत्न किया। और मैं धन्यवाद देना चाहूँगा और शुभकामनाएं भी अपने बेस्ट वर्कर और अवार्ड्स के अवार्डी को। और मैं धन्यवाद दूंगा कि वो लोग सबके लिए एक प्रेरणा का स्रोत रहें आने वाले टाइम में, कि उनको लोग देखें और अच्छे वर्कर्स साबित हों। और साथ ही धन्यवाद है इस सभागार में उपस्थित प्रत्येक व्यक्ति को और उनको भी जिन्होंने वर्चुअल मोड से ये प्रोग्राम में ये शिरकत की है। और साथ में जितने भी टेक्निकल स्टाफ यहाँ मौजूद हैं जिन्होंने ऑडिटोरियम को इस कार्यक्रम के लिए तैयार किया। और साथ ही सुरक्षा अधिकारी, सुरक्षा कर्मचारी, एडमिनिस्ट्रेशन, फाइनेंस, अकाउंट, स्टोर एंड परचेज के सभी व्यक्तियों को जिन्होंने परोक्ष रूप से पर्दे के पीछे रहकर इस कार्यक्रम को सफल बनाने में अपना सहयोग दिया। सभी स्टूडेंट्स को, सभी कर्मचारियों को धन्यवाद, थैंक यू। और आप सभी को चाय के लिए आमंत्रित, धन्यवाद, थैंक यू।
मैं सभी से अनुरोध करती हूँ कि कृपया राष्ट्रगान के लिए रुकें। सभी लोग राष्ट्रगान के लिए यथास्थान खड़े हो जाएं।
अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा, विंध्य हिमाचल
यमुना गंगा उच्छल जलधि तरंग, तब शुभ नामे जागे, तब शुभ आशीष मांगे, गाहे तब जय गाथा, जनगण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे जय 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 हे।
आज के कार्यक्रम से जुड़ने के लिए आप सभी का धन्यवाद। नमस्कार, जय हिंद।